Hi, I'm Dr. Muhammad Akbar Hussain. I'm a co-founder of Mareekh Dynamics for engineering solutions for human habitation on Mars. Right now, so today is 2nd of April, Sunday. We are at the northern tip of Lake Torrens. This is one of the largest salt lakes in Australia. It's a very ancient lake, formed hundreds of millions of years ago, and this has been a pristine landscape because it hasn't changed during that time. It has been a dry salt pan. It was once part of an ancient ocean, which after the uplift of because of the geological changes, this became a dry salt pan. It does fill up with water once every few years, but most of it is remain intact. So the main attraction of us being here is that there are structures that are possibly what we call fossilized stromatolites. Stromatolites are the colony of bacteria, the cyanobacteria, which were the earliest forms of life on Earth. And we see those living stromatolite colonies in shores of Western Australia and other few places in the world. We do see fossilized stromatolites in the sedimentary layers in many parts of the world. But here, the fossilized stromatolites are where they lived and died and got preserved in their natural environment and habitat where they were formed. And these could be hundreds of millions of years old. Now, what we find interesting is that this could be an analog to Mars, because if there was life on Mars, that would have been like many billion years ago, somewhere around 3.5 to 4 billion years ago. And if there was life, and if that evolved in the same way the life evolved and started on Earth, it could be the stromatolites. And once the Mars became uninhabitable, they would have died and must have got preserved. So if you want to look for life on Mars, you need to look for fossilized stromatolites, not the living stromatolites, because if there was life on Mars and if it evolved on the same lines as on Earth, they would have been stromatolites, which may be in their fossilized form and got preserved in the same habitat where they had evolved. So imagine that for example, the Perseverance rover that has landed in the Jezero crater next to the delta. That's where they may find the ancient remnants of life. Now, if there was any life, we say on Mars, there could be microbes, but microbes don't form fossils. But the microbial colonies, if they follow a special pattern of formation, if they form special patterns, the patterns get fossilized, and that's when we know that it could be an ancient fossilized life, which may look similar to the stromatolites here at the northern shores of Lake Torrens. And finding out the fossilized stromatolites might be a better proof of the evolution of life on Mars than finding living microbes, because living microbes could be a contamination from the probes or rovers sent from Earth. But if you find fossilized life on Mars similar to the fossilized stromatolites, they could be a more definite proof of existence of life on Mars. So here what we see, these concentric circles. I'll try not to step on any of these because they are pristine things. So these circles are concentric circles, and if you look closely, they always have a little mound in the center, and that's what a stromatolite colony looks like. They grow and they keep on growing outside, making concentric circles. And if you see, like for example, that one, this one has got a central structure, and they all these concentric circles. They're everywhere. They're all different sizes, and they're pretty much any exposed rock surface in this area would have fossilized stromatolites here. So we have found it interesting, and this is the first time I've been here, and I'm here with my co-founder Mehdi, who is making this video, thankfully. So this is where we are. This is the first time we've been here, and we are going to observe them and and then we're going to study about stromatolites, how they form, what are their chemical compositions. The main application of this concept I find is that if we could recalibrate rovers on, like for example, we have Perseverance rover on Mars, and if we could recalibrate it to tell what to look for in Jezero crater, so structures similar to stromatolites, that might be a better search for ancient life on Mars. In the future, what we can do is we can train the rovers in these sort of landscape to train them what to look for when they are sent to Mars, and this may be a huge stepping stone for our search for life on other planets. Thank you.